Hello guys, I would like to welcome you to show me how geometry. This platform is to learn about geometry and I'm ready to take you through the prerequisite skills for unified geometry. Please don't forget to subscribe to this channel so that you can come back to learn more on the videos that I'll be posting in the future. Thank you very much. All right, let's get started. So right here you have the prerequisite skills for unified geometry. I have been teaching geometry for a while now, so I put together all those things that all the skills that I believe that you should already know or be carrying um, with you from Algebra 1. Let's go ahead and look at all those things together so that we can be ready for the school year. All right, let's go. All right, here I have the operations, addition, multiplication, subtraction, division, the square root, and the absolute value. A lot of us might not be familiar with this here, the symbol right here. That's the absolute value symbol. All right. So we're going to be talking about how you apply all these operations to whole numbers, natural numbers, integers, and real numbers. We also have other forms of numbers, such as, let me say, we have rational numbers, rational numbers. You also have irrational numbers, and we have complex numbers. But we're not going to be doing a lot of we're not going to be doing complex numbers in geometry. Complex numbers. So I think you can do this a lot in algebra 2. All right. Okay. So when we talk about real numbers, it's I mean, it's everything about numbers except complex numbers. All right, let's get started with all numbers. Um, what are all numbers? So all numbers begin from 0. I would say all numbers mean 0, 1, 2, 3, 4, 5, and so on and so forth. And usually I would say these are counting numbers. You know, the numbers that you count. Usually when you count numbers, we do not begin from 0, but we know most people don't begin from 0, but we know that in order to count uh, numbers, we have to start from 0 all the way. Okay, so we have natural numbers. Natural numbers begin from 1, 2, 3, 4, 5, 6, and so on and so forth. So these numbers are called natural numbers. And you can already see the difference between natural numbers and whole numbers. So 0 is the difference here. All right. Let's go ahead and talk about integers. So looking at integers, we'd say, what about integers? So if you remember your uh, um, number line, coming from the elementary, if you remember your number line, all the numbers that are usually on the number line are called the integers. You can see this, right? So this is what you call integers, all these numbers here. It's going all the way to the left and all the way to the right. So 4 and -4 and so on and so on. So this examples of integers. And then when you're talking about real numbers, I would say the real number is a little uh, of more, not a little, like more details. It shows more in more details the numbers that are expected to be on the number line. So you have number line here. We can start from 0. You have 1, say 2. Let's do 2, 3, and come here. You have -1, -2, and -3. But remember that from 1, from 0 to 1, we can have 1/2. There's 1/2, And we have other numbers. We have 1/4, break it more. You have 1/4, just like that. And here, and so on. You even have 3/4, and so on. So there are a lot of numbers in between 0 and 1. And so you have a lot of numbers between 1 and 2, and so on. So all these numbers here are called real numbers. As a matter of fact, you also have other forms of numbers that are also part of real numbers, and numbers that you call rational numbers and numbers that you call irrational numbers. So rational numbers and numbers that you can write as fractions, like you can write as fractions, like for example, 1/2 is a rational number, 2/5, this kind of numbers, that you can represent as fractions. They're called rational numbers. But irrational numbers are numbers that behave like this, like square root of 2, maybe square root of 3. These numbers, when you plug them in your calculator, they do not have recurring decimals. Well, there are rigorous definitions for them anyways, and there are ways to prove that a number is irrational. So these are examples: square root of 5, and so on, something like that. And then when you see square root of 2/3, something like that, it is no longer going to be, rational, because you have square root of 2 as the numerator, and then you have 3 dividing that number. So these are examples of numbers I wanted to, talk about, because in geometry, especially when you calculate distance, you're looking at, sometimes you end up with a square root of numbers, or maybe you end up with radical numbers. So we need to review them. We're also going to be looking at how you can add them together. So all these numbers can be added, we can multiply, and we can divide, we can subtract, and we can take square roots, so we can find absolute value of these numbers. But let's look at some of these numbers here. Negative numbers, those we cannot apply square root to them. We cannot apply square root to negative numbers, but if we do, we will no longer be working in the realm of real numbers, and we would now be complex numbers. Say, for example, when I write the square root of -2, for example, this will not be considered as a real number, but it will be considered as a complex number. In the future, you'll be able to see and be able to rewrite this as I times the square root of 2. So when you start working on algebra 2, you'll be able to deal with numbers like this one. Okay. All right. So and I actually here is the square root of -1. That's the meaning of I, imaginary. So these are called imaginary numbers. So we don't want to go in details. Well, let's keep going. And we can add this number, like I said, we can multiply them, so we can apply this. So we haven't talked about absolute values. In the future, we're going to look at that. For example, we're looking at absolute value. When I write 3 and put the symbol on it, apply the symbol to that, or apply this operation to that. So what does that really mean? We'll see that that's going to give us exactly 3, as well as if we apply the absolute value to the -3, and then we say the absolute value of -3 is still also going to be what, 3. So when you talk about absolute value, you can you look at the number line right here. Number line has integers on them, so you're just looking at the distance of that number from 0. For example, the distance of 3 from 0, the distance of 3 from 0 is 3 units. 3 units. So that's why we say the answer here is 3. And if you look at this -3 here, the distance of -3 from 0 is also 3 units, because you just count 1, 2, 3. So, and then you also have 3. So absolute value, when applied to negative numbers, will lead to positive results. So this is what we're talking about here when we talk about the absolute value. All right, so today we have been able to review all these numbers, know the difference between whole numbers and natural numbers, integers, and we talked about real numbers, which we're going to be dealing with in geometry. We're going to be dealing with real numbers, well, and then we're going to be talking about, and real numbers include, you can see a real number includes integers, natural numbers, whole numbers, and rational numbers, irrational numbers. So, but then only complex numbers does not belong to real numbers. So we're going to be operating these numbers. We're going to be multiplying them, adding them, and so on. But then we're not going to do complex numbers right now. So thank you for joining this lesson to review these numbers, and I will see you on the next episode.